So tomorrow, you will have a formative assessment that you can take in class. And you will have your homework, that yellow page of homework will also be due. Okay? So those two things are the only thing that we have scheduled for tomorrow. Okay? So just so you know, you'll have time tomorrow to get some stuff done. Okay? So solving linear equations. Okay? So a couple of algebraic reminders, if you will. The first algebraic reminder is, of course, our old pal, the golden rule of algebra. Whatever you do on one side of an equation, you've got to do to the other side of the equation. So if we're adding 5 on the right side, we're going to add 5 on the left side. Dividing by 7 on the left side, add 5 by 7. Otherwise, our equations become imbalanced, okay? And we want to keep it in balance. Okay? Second, to move something to the opposite side of the equation, you're going to need to do the opposite. So if it's adding, then we need to move it. We're going to subtract. If it's square rooting, we're going to need to square. Third, our answer always is in the form variable equals some number or number equals some variable. Okay? And this one, that is not solved. Okay? That is not solved. When you've got a variable all by itself, but it's still got a coefficient, then it's not all by itself. So we need to have just the variable. So we want h, just h. Okay? And lastly, the nice thing with equations is that we can always check our equations. Okay? Plug it back in, find make sure we got a true statement, not find. Okay? Plug it back in, draw all the x's, or all the whatever the variable is, and make sure we have a true statement. Love it. All right, let's do this. Okay. Today we're just going to focus in on linear equations. As the class progresses, we'll get deeper and deeper into higher level equations, but right now we're just straight up going linear. Okay? In letter A, what do you want to do first? Let's go. Subtract 9 from both sides? I would actually go subtract 9 because I don't want to get, because I've already got all the variables on one side. Right? Oh, we're not scared of negative numbers. No. So we're going to subtract 9 from both sides. Again, I'm a writer-outer of stuff, but I be the teacher, so I write. Then, divide both sides by -4. That's going to give me x equals 8. Right? Checking it, plug it back in. Let's be in your head. As we get more complicated. 4 times 8 is 32, right? 9 minus 32 is negative 23. That's a true statement. So our answer here then would be x equals 8. And because we checked it, we've got the right. We've earned the right to put a little box on so that we know where it is. Questions, comments, concerns, clarifications? Love it. B. What do we do? Whoa, tap the brakes. You gotta be more specific. Okay, right? Okay. So I'm going to add x to both sides. Because that's going to get rid of that one. Okay. Now, if you're okay with doing those at the same time, I'm okay with it. Okay. If you're not, break it up into 2 steps. Yeah, you can definitely do those at the same time. That gives me 8x equals 18. Now, both sides by 8. Nine fourths. Okay, because I don't like 18/8. Both can be divided by 2. So I like 9/4. Now, do I like 2.25? Do I like 2.25? No. No. Okay. Keep it in fraction form. We are not scared of fractions. Okay? We are not scared of fractions. We shouldn't be scared of fractions at this point in time in our academic careers. Fractions are cleaner than decimals. You don't have to worry about rounding. You don't have to say, oh, what decimal place do I need to round to? No, it's a fraction. Okay? Number over number, done. Okay? Much, much cleaner. Okay? Checking this one. So 7 times 9/4 is 63/4. Minus 3 is like minus 12/4. See what I did there? 12/4 is 3. But now it's in common denominator form. Okay? So the left side of this equation is 51/4. Negative 9/4 plus 15. 15 is how many fourths? 60. So the right side is 51/4. Now we got a true statement. Both sides. Questions, comments, concerns, clarification? You try those 3. Because I'm not feeling 100%. So I'm wearing it for your protection. So first off, I'm going to subtract 9. That leaves me with this up a little bit. Oh, what's that? Negative 41. Okay. Multiply by 5. Okay. Can I I multiply by -5/4. Yeah, because then that does it both at the same time. Or if you multiplied by 5 and then divided by 4, or by -4, that's fine too. Yeah. So, left side, get x. For right side, we've got 205 over 4. -4/5 times 205 over 4. 4's cancel out. 5 goes in there 41 times. So we've got 9 minus 41, which is -32. Check that. Extra side note, big fan of mixed fractions, or not mixed fractions, improper fractions. Not a fan of mixed numbers. Not a fan here of 51 and a fourth. Okay? Big fan here of number 2. If I'm going to combine these two, because they're on the same side, I first got to have a common denominator. Yep, exactly. My common denominator is going to be 15. 2/3, 3 to get to 15, I multiply by 5. So 2 times 5 is 10. And then I'll put the x on top. 5 to get to 15 is multiplied by 3. So then that gives me 9x. And that is equal to 4. 10x over 15 minus 9x over 15 is 1x over 15, or just x over 15. Multiply both sides by 15. And x equals 60. 2/3 times 60 is 40. 3/5 times 60 is 36. 40 minus 36 is 4. Checks out. Subtract 0.5. Leaves me with 0.6 g equals 2.4. Divide by 0.6. Four. 0.6 times 4 is 2.4. 2.4 plus 0.5 is 2.9. Try these two special situations, and let's talk then a little bit about what they mean. Okay? So on the left one, we'll take the left one first. What should we do first? Distribute the 5 in. Okay? So that's going to give me 5x minus 20, and that's going to equal 5x plus 12. Now what? Subtract 5x equals 7. Okay? That gives me negative 20 equals 12. What's wrong? One doesn't equal the other, right? Okay, so that's one problem. They don't equal each other. Okay? And more importantly, where'd my variables go? They gone. Okay? So the variables are gone. And we have a false statement. What is our answer? No solution. So there is no number that will work in this, equation to make it work. No solution. Next one. Again, I'm going to multiply by 5 into the parentheses. At the same time, I can combine these two, and I can combine those two. Add 5x. Now I've got 10 equals 10. So what's my answer here? Variables are gone, but I have a true statement. All real numbers, yep, or infinite solutions. Yep. Not just infinity, infinite solutions. See now, Mr. Eno, what I mean about totally opposite? Well, so do you see what I mean by total opposite? Yeah. Because one's got none, the other one's got all of them. Okay. I would also here accept on this one. I don't know if you guys know the symbol for all real numbers. That would work too. Okay. Or infinite solutions. Okay. All of those mean the exact same. Okay. Yes, we will have word problems. Yes, they come up every once in a while. Okay. So, does anyone in here, before we do this problem, does anyone in here know where the most mistakes are made in a word problem? Reading it. Or the lack of reading it. Okay? Right? So, the most mistakes are made in a word problem in the reading part. Okay? So, I recommend that you read it through twice. Okay? John rents a sailboat on vacation. The boat has a rental fee of $45 plus a $7 per hour fee. If John is charged $101, how many hours does he rent the sailboat for? Okay. So first step, we're going to read. We're going to reread it in step number 2. Step number 2, we're going to make equations. Okay. So John is renting a sailboat. You know that. Boat has a rental fee of $45. So no matter what, he's got to pay that $45 flat fee. Okay. So what would that be in my equation? Plus 45 somewhere in the equation, right? Okay. So let's start out with plus 45, or positive 45. Plus a $7 per hour fee. Okay? So we got to come up with a variable here because we don't know how many hours that he's rented it for. So what do we want to use for hours? X. Okay, that's fine. So that's going to be plus is plus what? 7x. Yep. Okay. So that's how much that this business, that's their business model. Okay. 45 plus 7x, where x is the number of hours. Okay. So then what did he get charged? 101. So where's that going to go? Equals 101. Yeah, love it. Okay. Now we're going to solve. How do you want to solve it? Correct. 45 on both sides? Love it. $56? Then? Divide by 7. Okay. And then lastly, what we're going to do is we're going to check it. Now, this check is based upon us making our equation correct, right? So this check is actually a two-pronged check, okay? So the first one is, does it make our equation true? Okay? 7 times 8 is 56, plus 45 is 101. So it makes our equation true. The second prong on this check is, does 8 hours make sense? Okay? In this case, it does, right? Okay? It makes sense that he rented the sailboat for 8 hours. Okay? What I mean by things that don't make sense is, what if we would have gotten negative 8 hours? Okay? Hard to rent something for a negative amount of time. Okay? Or if it's a people problem, if we've got 7.38 people, that's an issue. Okay? So we have to check to make sense. Okay? So he rented the boat for 8 hours. Now, notice what I also added to my answer. A label. Word problems have labels. Word problems have labels.
Is that realistic? Like for a boat, like for $7?
just made it up. I wanted it to work out, you know what I mean? So, yeah. Usually the rental fee, like the straight up fee, that's usually a lot. Usually that's 3 digits. For one vote. Oops. You, try that. A salesperson at an electronics store has a base salary of $10,000 per year and earns a 15% commission on total sales. How much must the salesperson sell to earn $25,000 a year? So, read the problem. Make an equation. Starts out at $10,000 a year. Then on top of that, he gets added 15% of the total sales. So that's 0.15, 15% is decimal point of 0.15. And we want to make $25,000, or he wants to make, or she, or whoever wants to make $25,000. So first we're going to subtract off 10,000. So that's going to give me 1,000 divided by 0.5. $100,000. Okay. But what is that 100,000? Dollars, right? Dollar bills, y'all. Okay. Good times? Good times. That's how much he has to sell. Yes. Yes.
Well, if I had as soon as I saw it, I was like, oh, I would make $100,000 a year. Then I was like, wait, that's not what he's making.
No. He's got to sell $100,000 a year.
Right.
Only to make $25,000.